Next, let's look at design input. We're starting where we left off in Act 2, here in the product requirements document, looking at the traceability downstream to system requirements. Let's follow one of those links. We're now looking at the system requirements document. If we apply this view, we can see the traceability back to the product requirements upstream, as well as to the software requirements downstream. For example, system requirement 4812 satisfies product requirement 4968 and itself is satisfied by 3 software requirements. Next, we'll put these requirements through a review cycle. But before we do that, we're going to use the power of AI to check and improve their quality. Now, it's likely that we'll need to edit the requirements, so let's start by creating a change set to encapsulate any changes we make. Note that our engineer, Susan, is now working in her own private area. Any changes made here are now isolated from the rest of the team until they're delivered. In a real project, we would trace this change set to a work item, and the platform can even be configured so that we cannot deliver any changes back to the team without a work item with the appropriate approvals on it. You'll see those approvals in a moment when we look at reviews. For now, let's just check our requirements. This view filters the document to show only system requirements and also adds columns for some attributes that will store the results of our quality check, which is useful for reporting later. Let's select all of our requirements and we'll ask the Requirements Quality Assistant, or RQA, to check them. RQA analyses the requirements using Watson Natural Language Processing and then scores them against the rules defined in the INCOSE Requirements Engineering Handbook, or indeed against custom rule sets for specific projects or domains. Here we can see that most of the requirements have scored well, but a couple need some work. Let's take a look at one of those. First, RQA gives us the reason for the score. In this case, we have an unclear term. The phrase, in a clear manner, is ambiguous and subjective, which makes it very difficult to test. Detailed guidance on how to improve poorly written requirements is included, an essential tool to help less experienced requirement writers improve their skills. Now note this isn't something as simple as a keyword search. The requirement below this one also has the word clear in it, but in that context it's not ambiguous and that requirement scores 100. RQA goes beyond simple keyword searches. It can understand context, meaning and intent. And we can fix that requirement fairly easily. In this case, that ambiguous phrase is actually not needed at all, so let's remove it. Then we can ask RQA to recheck just that requirement. Identifying and fixing quality issues like ambiguous, incomplete and poorly structured requirements before a review saves time and reduces cost. Domain experts can spend their valuable time reviewing the intent of a requirement rather than wasting time fixing things like inconsistencies. In a real project, we would of course fix all of the issues and deliver the requirements back to the team and then create a baseline of those requirements ready for the review. Now, as this is a demo, I've already created that baseline and the review, so I'm just going to discard this change set. And then I'll switch from Susan's personal editing area back to the team area. Let's look at reviews. So as per ISO 13485, requirements need to be approved and reviewed. So let's return to our dashboard and we'll see how a review cycle takes place. Here we have a work item to review the system requirements for the infusion pump. Here on the Approvals tab, there are several approvals that are required to complete this work, the reviews themselves, and a final managerial approval. Here on the Links tab, there are several links. The review baseline is the document that our reviewers have been asked to review. This child task is an issue that was raised during the review. And lastly, the approved baseline is a link to the baseline document after the review was completed and the requirements were approved. Let's start by clicking the Review Baseline link. Now note that the System Requirements document has now opened, but in the context of a baseline, and so these artifacts are all frozen and cannot be edited. Let's go back to the work item and let's click the child task. Now here we can see that this is an issue raised by one of our reviewers, Dan, and he's assigned the work item to Susan to resolve. At the bottom, we can see a description of Dan's issue. He doesn't think the requirement's complete enough, and he's also identified a potential missing requirement. Further down, we can see that Susan has replied. She agreed and made some changes to the document in response to the review comment. Now, all of this conversation is, of course, held for an audit trail. On the Approvals tab, Dan added himself as the approver. Now, note that the parent review work item would not have been allowed to close until all of its children were also approved and closed. So any issues raised during the review would prevent it from completing until they were addressed. On the Links tab, there is a link to the requirement that had a problem, which helped Susan identify it in the document. Let's follow that link and take a look. Again, we are in the context of the review baseline, and the requirement reads, the system shall perform self-test on initiation. Now, as we saw in the work item, Susan agreed with the review comment that this was not complete enough and made some changes. After that, the review work item was approved and closed, and another baseline was taken and electronically signed. Let's switch contexts. Let's take a look at that baseline and see what happened. Now, it may not be immediately obvious what the changes were, but the ELM platform allows us to compare artifacts to see any differences. In this case, let's compare this approved baseline to the original review baseline. Here, we can see the additional requirement that Susan added, as well as the existing requirement that was modified is highlighted in blue. And we can dive deeper into that requirement and see the details of any modifications that were made. Let's now close that comparison and return to the document. Next, we can follow this link to the actual approved baseline, and there we can see its electronic signature. Now let's look at risk management. First, we'll return to our project dashboard, and once again we'll switch back to the main team working area. Here on our dashboard, we have two tabs of interest: FMEA, or Failure Modes and Effects Analysis, and Operational Hazard Analysis. Now, there are many similarities between the two. They both examine failure modes, effects and causes. The primary difference is that Operational Hazard Analysis focuses on what could go wrong if the product is used incorrectly, whilst FMEA focuses on the identification of possible failures in the design of the product components. Let's start with FMEA. Our dashboard is surfacing the results of the FMEA in a consumable way. For example, at the top here we have a traceability view, from the system requirement to a potential failure related to that requirement, to the safety requirement that was created to mitigate against the risk of that happening. On the right, we have more of a metrics view, how many failure modes are mitigated by safety requirements and how many are not. Now, these are not just pictures, of course, this is all live data. Let's use the traceability view to navigate into the FMEA document and see the analysis. Here, we can see the columns of information that allow us to perform the FMEA. The identified failure mode, the effects of that failure, its potential causes, and any current controls we already have in place. Now, those assessments allow us to assign numeric values for severity, probability, and detection. And those can then be used to calculate the risk priority number, or RPN, which is a simple measure of comparison. Now, here too the platform can help by automating steps or performing calculations on the data. Let's see an example of this in action. We'll start by making a change set. so that we can make some changes to this data. Then let's edit this risk priority number and actually delete that value. Now in our mini dashboard, we can expand this RPN calculator, which will perform that calculation for us and populate the field again. Now, of course, that's a very simple example and a very simple calculation, but it shows how the basic capabilities of the platform may be extended with automation widgets like these. Okay, let's go ahead and discard that change set. And as before, we'll also switch back to the team area. Back on our project dashboard, let's now select Operational Hazard Analysis. Now, that analysis is performed in much the same way as FMEA, with the major difference being that these hazards are the result of user error rather than device failure. The ELM platform allows for automatic generation of federated documentation. Here we have a link to an automatically generated document that combines both of those analyses into a risk management file.